Assalamu alaikum. In this mini project, we will use Arduino nodes to get sensor readings to display them on an interactive website using Kafka as a middleware. Let's get started by looking at the components needed. First, we will need 4 Arduino Mega, 4 Wi-Fi shield, 3 base shield, 2 temperature and humidity sensors, 1 gas sensor and 1 sound sensor. Each node readings will be published on a certain topic. Node 1 will publish on a humidity and temperature topic. Node 2 will publish on temperature and sound topic, and Node 3 will be publishing on the gas topic. The LoRa client nodes will send the sensor readings to the LoRa gateway. Then we will get the readings using the BiSerial library. Then the Kafka producer will publish the data on its suitable topic. Then the consumer or a set of consumer will read the data and send it to the client app. LoRa nodes send sensor readings to the LoRa gateway. Then LoRa gateway is used by the Kafka producer to get the sensor readings. Kafka producer publishes the data in their appropriate topics on the Kafka brokers. Here in this case we have 2 brokers for reliability. Then the Kafka consumer reads the information from the broker, depending on which topic it is subscribed to. The client uses the data from the Kafka consumer to be used or displayed by the user.
This is an explanation for the Arduino code used in this project. We first see the libraries that we used. DHT library for the humidity and temperature sensor, SPI for reading from the serial port, LoRa for the LoRa shield used in all the nodes. Arduino JSON is for the JSON format messages that we use to send and receive. We define the pins that are used in the sensors. So the first method setup, we make sure that the LoRa is running. We say that LoRa is sending. If it is not running, we go into an infinite loop. We created a JSON object that we added the needed data, and we sent it to the using LoRa. The code here for the gas node is almost the same, nothing new included. For the sound and temperature node, we can see that the temperature part is the same. The sound part only has this method, which is different, to read from the analog port, and it is also sent. The receiver code is taken immediately from the LoRa library from the examples. That's the explanation for the Arduino codes. This is a demonstration for running Zookeeper and Kafka on 2 different machines. We're gonna see Zookeeper running on machine 1 now. We can see it says binding to port, which means it is working now. Now we're gonna run Kafka on machine 2. And we can see that it's also started. And the messages on both machines can show that the Zookeeper and Kafka connected. Now creating a topic and listing the topic on machine 1. The topic will be created on machine 2. And we can see that it says created topic. On machine 1 we'll see a listing of the topics. And it shows the topic 2, which is just created. Now we're gonna create a producer and a consumer on machine 1. The producer on machine 2. It's running, and the consumer on machine 1. And as can be seen, there is an error which always happens, and we tried to search and fix this error, but unfortunately we couldn't fix this error. This is the end of the demonstration.
Let us have a look at the producer's code. We implemented the producer using Python. We used the Python Kafka library to create the producer. Also, we used the serial library to read from the serial port, and we used the JSON library to send the JSON formatted messages. To create the producer, we need to specify the host name and the port number. Here, because we are running Kafka on our machine, we are typing the localhost. If you are running Kafka on another machine, we need to type the IP address of that machine and the port number of it. Here we are specifying the encoding type to be for the data to be encoded and sent to the other machine. And now we enter the while loop to publish our data. First, we created a dictionary object to hold the data that we received from the serial. Then we check for the ID of each node to publish to the suitable topic. Then we have a sleep for 5 seconds as requested, and also we faced a problem that the data was overwritten when we published 2 messages at the same time.
So for the consumer part, we are using Kafka Node. Of course, we are using Node.js. So we are required Kafka Node here, and we are calling the consumer offset client. Of course, here we are creating the client, so to connect directly to Kafka brokers. Then, of course, the Kafka are working in the background, Kafka and Zookeeper. Then we create some topics that we need. So in our case, we need 4 topics: temperature, sound, gas, humidity. Some options. Do consumer. So here we are creating the consumer, the new consumer equal client, topics, and options. That the ones that we create. So here we are defining object data. We consume the message through this method. We put the data equal the message. Then we are sending it to this to router.get. It's for sending the message. So we are receiving it from here, API. We are using the same name, API. Then we are receive the message from here, the result, and this result is just we just do some JSON parse to make it as a JSON. Then we make check if it's a gas. We just graph it. .push. We put it in this gas data to graph it. Or if it's a temperature, we put it here. If it's sound or humidity. So this is for the chart part, and we do it here. It's simple for the chart part. So the resume and stop topics are the second part for consumer. So we use router.post API 2. So we are receiving here. So here in a click function we have temp, gas, humidity, sound. So which button is clicked? If the temperature is clicked, we check if the temperature is on. So we put the temperature is on, and we send it as this data.topics is temperature, data.stats is on. So we are receiving it directly from here. When we receive this request, the body topic, which is it's the topic. So we do consumer post topics. This is if it's off. If it's on already, so we do the opposite. We resume the topic. This is for the request, the body. Also, we know the topic. It's what it is. So this is the consumer part. It's easy. Now let's go to the demo. Okay, so we start with node1 start. Of course, node1 is to run the server. So we start running the server on the local host, as we see. So here we have a graph for each topic, and we can see the data are coming. Of course, when we pause some topic, the data will stop coming. And when we run it back, it will come back again. Here we have another example when we run the system again.